Kia ora Year 11 and 12. Here are questions 2A and 2B from the 2018 Level 2 Calc paper. So question 2A is one that comes up all the time, and we're given the graph of a function. So here's the function, y equals f of x, and we can see that it's a parabola, a quadratic. And underneath that, we have to draw the graph of the gradient function, f dash of x. In other words, we have to think about the slope all the way along that curve. So the easiest thing to do is to look for the place where we have a maximum or a minimum, because we know that here, where I'm drawing in a tangent that is horizontal, the gradient function must be 0. And that's the first point that we're going to put onto our graph down below. So at x equals -1, we've got a gradient of 0. Now let's look at what the rest of the function looks like. Well, we know we've got a quadratic. So if f of x is equal to some kind of parabola, right, an upside down one, then we know that the gradient function is linear. You don't have to do any of this working, right? But in your head now, you should see, when you see a parabola, you should think, oh yeah, that's got a linear gradient function. And that's all you have to do to get this question right. So if we look at the parabola, what can we say about the gradient on this side? Well, the gradient here is positive. And on the other side of the maximum, the gradient is negative. So if we go back down to this one here, we're going to get a ruler and we're going to draw a straight line which is positive below -1 and negative above -1. Let's get rid of the ruler. So some kind of line like that. It doesn't matter. Nothing else about that line matters, right? But the thing that we're looking for is that you understand that a quadratic is a linear gradient function, and that you can identify that this point, the maximum, must match up down here to the 0 point on the gradient function. Okay, so do lots of practice at these problems because they do take a while. The Walker book has got lots of them, and the Theta book does as well. It's easier in the Walker book because you can just write on the pages. Okay, on to the next one. So this is another classic, which is about a skyrocket, and we're given the equation for the height of the rocket after it is launched, t seconds after it is launched above the ground. And again, we've got a parabola here. Now this time we're asked to figure out the maximum height that the skyrocket will reach. So let's think about what that graph looks like. Well, the rocket is launched at t equals 0, and it's going to go like that. So we're asked to find the maximum height. We have to make sure that we do that using calculus. So your graphing skills are quite good now, so you can pretty easily figure out by factorizing where this vertex is going to be. But don't do that. We want to do that by saying, well, we understand that the gradient at the maximum is equal to 0, so where will that be the case? So we're going to start by writing that down. So max height is where h dash of t is equal to 0. So let's differentiate. We've got h of t is 39.2t minus 4.9 t squared, and h dash of t, the gradient function, is 39.2, take away 9.8 t. Now we have to solve that equation equaling 0. That gives me t, let's go slowly, 9.8 t is equal to 39.2. So t is equal to 39.2 over 9.8. That gives me t equals 4. So that's telling me that after 4 seconds, the rocket will be at its maximum height. But that's not the end of the question, because we were asked to find what that maximum height is. So we're going to take t equals 4 and we're going to substitute it back into h. So h of 4 is equal to 39.2 times 4 minus 4.9 times 4 squared. And that equals 78.4 meters.